Okay. I feel like the first study guide isn't too bad.
Mm-hmm. So is there like specific questions that you guys want to ask, or do you guys want to cover the protein structures?
Yeah, we can do that. I'm down with that.
There you go. You can hear it now. So, but like, am I muted?
No.
Can you be? I don't know.
I can hear you, Angela. Perfect. Okay, let's go over the protein structures then. So how many types of protein structures do we have?
No idea.
Is it 4?
It's 4, yes.
Okay.
And do you guys know what they're called?
Primary, secondary, and the rest, right?
Primary, secondary, and what's after secondary?
Tertiary.
Yes. And there's one more.
The fourth one.
It's quaternary?
Yes, quaternary, right? So what happens in primary?
Huh?
You have to send her the
Oh, okay. In the chat?
Yeah.
Can someone tell me what's a primary structure? Anyone?
A primary. It's a sequence of amino acids and a covalent bond and a peptide bond.
Yep, it's amino acids bonded like in a phase, and they're bonded by polypeptides. Yeah,
I can't hear.
they're covalently linked together in a long chain. It's called polypeptides basically. And do you guys know what's at the terminal when they make a bond together with each other?
A peptide bond? Why does it sound like that?
It's very loud in the back.
I think it's because 2 of you are in the same room.
Is it because what?
I think 2 of you are in the same room, so.
Yeah.
Okay, please.
Yeah.
Come on. It doesn't matter.
Do you guys want to put headphones in? I think that might lower down the voice or noise. So what's at the end terminal when they make a bond in terms of polypeptide? So it starts with certain group, right? Then it ends with certain group. What are those terminals? What are they called?
And terminus. And I don't know the other one.
And does anyone else know? So it starts with amino group, right?
Mm-hmm.
What does it end with when it makes a polypeptide chain?
A carboxylate group.
Carboxyl group, yeah. So the way they make a bond, it's amino acid, like carboxyl group of the first one making a bond with an amino group of the second amino acid. And then it goes on. And what happens in the secondary structure? Anyone?
I've written down like alpha helix and beta sheet and loop and all that.
Yes. So there are two different type of interactions, right? Alpha helix and beta pleated sheets. What are alpha helix?
Coil shape.
And in what direction do they coil? To the right or to the left?
Right?
To the right. So it goes like this in the right direction. And what's beta pleated sheets? How many types of beta pleated sheets do we have? There are two. Do you guys know what they are?
I don't.
Okay, so there's parallel and anti-parallel. What do you guys think when you listen to the name parallel or anti-parallel? How do you think they make a bond together?
Parallel, they just don't touch.
So parallel, it's like they have N-terminal and N-terminal on the same side. And if it's anti-parallel, it's like N-terminal on one side and C-terminal underneath it. So they're opposite from each other. And what's the bond between them?
In the anti-parallel?
What's the bond that keeps them? I'm sorry?
OH bond?
OH bond, I don't think that's a right name, but yeah, it's hydrogen bonding.
Yeah.
Yeah, so it's like hydrogen making a bond with another hydrogen, right?
Mm-hmm.
And what happens in tertiary?
It finalizes into a 3D shape.
Yep, it finalizes the 3D shape. And quaternary?
Multiple protein chains.
Yep, multiple tertiary combined together, right?
Yes.
Okay. And do you guys know how to do the charges for amino acids since you guys have exam tomorrow? That was on I think the study guide question.
No.
Okay.
Is that like how we figure out like if the pH is bigger or smaller than like Oh, okay.
Yeah. Do you guys feel comfortable with that or no?
And there was like one of them that was like neutral and I didn't understand understand why.
Which one was it? What study guide was it again? I can pull that up.
Let's see what the guide it was. But maybe it was just an example we did in class. Let me see. I don't know. It's okay. It's okay. It was just like the pH was 8.
Mm-hmm.
The pKa is 6 for H. It's for his.
Okay.
And then that one, he said it was like neutral, and I didn't get why, because 8 is bigger than 6 for the pKa, so I thought it was like negative because it's depronated. Does that make sense? But then he put neutral, so I'm like,
Was there another group, like a carboxyl or the side chain that he
yeah,
looked at?
the side chain, like it says his and then R and then NH3+.
So I think he might have said neutral because if you have a plus and minus on the same chain, then it cancels each other, so it becomes neutral.
Okay, that makes
Yeah.
okay.
Mm-hmm.
Okay.
I don't remember what question it was, but we had a quiz online, and I thought the answer was +2, but it ended up being +4.
I remember that one too.
Are you in Brooks's class too?
Yes.
Okay. I think I have the you guys only took one quiz, right?
Yes.
Okay. I have the question. Let me pull it up really quick.
Oh yeah, it's the net charge of the following peptide at pH 1.
What number is it?
7.
So let's do it on here. So what's the first amino acid that we have on this particular chain? So the question is, what would be the net charge of the following amino acid at pH 1?
Mm-hmm.
And the first amino acid is arginine, right?
Mm-hmm. Yes.
And do you guys want to kind of work it through while I set my iPad with it? I can share the screen with you guys.
So arginine is a plus, right? +1.
What are the pKa values for arginine?
Oh.
Because I don't remember them from top of my head. pKa values.
I'm trying to remember which pKa, because there's 3 pKa.
Let's do it this way. Here are the pKa values.
Yeah.
And the first one we're looking at is arginine, right?
Mm-hmm.
Which is right here. And what groups are we going to look at for arginine? No, that's asparagine. What groups are we going to look at for arginine when we look at the charges?
What do you mean by what group?
Yeah, I don't understand.
Because the way we draw them, it's an amino group. There are 3 different parts to arginine, right? There is an amino group, there is an R group, and there is an alpha group. Amino group, carboxyl group, and R group, sorry.
Mm-hmm.
Are we going to look at all 3 when we determine the charge? 2 or only 1?
1.
Why would you say 1?
Or is it 2? The amine group?
If it's 2, why and which ones?
It might be 2 because there's 2 amine groups connected together.
So the way it works, it's We have arginine, right?
Mm-hmm.
It's making a bond with lysine. That's the next amino acid in line, right?
Okay.
No, actually it's serine. So it's the carboxyl group from arginine is making a bond with an amino group of serine. So we're gonna only look at the R group of arginine and the amino group of arginine, not the carboxyl group, because that's already making a bond with another group. So it can be protonated or deprotonated.
Okay, so for arginine, we're looking at the R group of it. You said.
Yes, we're looking at the R group and the amino group.
Okay.
Do
So
we have to do that thing where he said in class, like in the beginning of all of these, the NH3 plus, like we have to have that, and then at the end it's the.
It's the carboxyl group, yeah.
And so then do we for those ones we look at pK, the second row, right? pKa.
Do you mean for the last one?
Like for the very first one.
For the very first one, you look at the pKa of 2.
Yeah.
And pKa of 3.
The rest, it's like whatever is only on the third one, right?
Yeah, for the middle ones, whatever is on the R group, yes.
Okay.
The side chain, yeah, which is the pKa 3.
Okay.
Yeah. Did you guys got the pKa values?
okay, yeah.
Okay. So what are the pK values and what's the charge?
So the first one would it be 9.04?
The first one is 9.04. And what's the second one that we're going to look at?
Oh, the second one that we're going to look at. So 4.25.
Wouldn't be 11.48 because that's a pK value of the side chain. So we have arginine, right? And here's the amino group. And then the R group. And serine. And the pKa value of the R group is, let me see. And what's the pK value of the amino group? 9.4. And is pKa less than pH? Or pH less than pKa?
It's more.
And when pH is more than pKa, it deprotonates, right?
Okay.
And that means is it going to be +1 or -1?
Maybe plus.
When it's deprotonated, it's minus.
Oh,
So it would be -1. Because we're looking at pH 1. Since it's less, that's
okay, so it was +1.
yeah. Since pH is less than pKa, it's protonated, so it's +1.
Okay.
And for the R group, is that more or less than pH?
It's more again, so it would be +1 again.
And +1.
Okay.
And for serine,
How did you get the R group pKa? Sorry.
this was the third pKa value listed in the chart. It will be given to you on the exam.
Okay.
Yeah. And then after serine, we have
Oh,
and the one thing to keep in mind, the middle ones, we only look at the R group. Do you guys know why?
Because their terminus are connected to the rest?
Yes. So what is the pK value of the R group of serine?
it doesn't have one.
Yep, it doesn't have an R group. How about for GLN?
Which one's GLN?
Oh, sorry. It does.
This one is glutamine.
So it doesn't have one either.
It doesn't have it either. Perfect. And what's the next one?
3.65.
Is it 3.65? Yep. And is that more or less than pH?
It's more, so it's still +1.
+1. And after aspartate, we have lysine.
So 8.95 for that person.
And what's the pK value of lysine?
8.95 for that first one. For the R group, right?
For the R group, would it be 8.95 or 10.53?
Oh, 10.5.
10.53. And what would be the charge for it?
+1.
+1. And for the last one, what are the two groups we look at?
The R and what was it? Carboxyl?
Carboxyl.
Mm-hmm.
And what would be the charge for the R group?
That would be the one that's 8.95. Right?
This is still 10.53 because we're looking at the R group.
But for the carboxyl, that's the.
For carboxyl, it would be 2.18.
Oh.
8.95 is the amino group. Since this is 2.18, what's the charge for it?
Would be positive and negative. Is it neutral?
Wouldn't it be positive? So we get 1, 2, 3, 4, 5, 6. And you said the answer was 4?
Mm-hmm.
It might have been, or maybe I thought it was 4.
It is 4. But I think that doesn't that carboxyl it's positive, but then doesn't it cancel with the negative? Like I don't know.
Because even for the R group, it's 10.53. Which makes it positive. One, 2, 3, 4, 5, 6. How does he get plus 4? Because this is the math that you're supposed to follow. Look at the pH and compare it to the pKa, and either give it a plus or minus charge.
Does the pH one do anything? Like if they give us a different pH to?
If let's just say if it was they gave you pH of 9, right?
Mm-hmm.
And since this is in this case the pH is
Oh, okay.
more than pKa, so
Mhm.
it'll be -1.
Okay, I see how it changes now. Okay.
Yeah. So that'll help you to determine if it's gonna plus 1 charge or -1 charge when you
Mhm.
compare both of them.
Okay.
Yeah. I think we got all them.
Okay.
So then what's the answer?
I'm getting +6.
That one wasn't one of the options, I don't think.
That's why I'm double checking. Because that's 3.65. 10.53.
I wonder if that last one has negatives for some reason.
But why would they be negative?
Because they're connected to the carbox. I don't know. It's like COO minus.
Hi, Karen.
Because we pH is 1 and pK is 2.18. That makes it positive.
Do you know if it's all going to be multiple choice or if we have written ones too?
I feel like it's a mixture of both. Yeah. That's how it was for me. But this is a method you're supposed to follow. I'm not sure why he's getting +4 instead of +6.
Quick question about the protein extract.
Mm-hmm.
Do we need to like other than what we went over, what else do we need to know? Like, how much in detail would we have to know?
I would say for him, just know whatever he said in lecture and what's on the PowerPoints.
Okay.
Yeah. Because from what I know, he won't give you anything outside the PowerPoints.
Okay.
Yeah. He must have told you guys not to use the book, right? Did he?
I know. I haven't looked at
Yeah. What else we can do?
it.
And what's the amino acid that can be protonated or deprotonated at pH 7? You guys know?
Can you repeat the question, please?
So what amino acid can be protonated or deprotonated at pH 7?
All the amino acids.
There is a special one.
What?
It works both ways. It can be protonated or deprotonated depending on how it's supposed to be in order to stabilize the substrate.
Is it ASP or glycine?
No.
I have two notes actually, and one
What amino acid is this?
oh, it's histidine.
Histidine. That was one of the quiz questions, right?
I will see right now on my notes.
Yeah.
What's the one that can be protonated and deprotonated?
At pH 7. And how do you know if something's an acid or something's a base?
Based on their charge.
Can you expand on that?
Sure, if they carry a positive charge, then it's base. If they carry a negative charge, then it's acidic.
That's true in some scenarios, but let's just say we have these two. Which one is an acid and which one's a base? Or acid and a conjugate base?
First one, it's acid. Second one is conjugate base.
Yep. So keep in mind the one with more hydrogens will be your acid. And conjugate base, it's after it's lost either 1 or 2 or 3 hydrogens.
After it's lost hydrogen?
Yep. Because when we do a reaction, acid reacting with base, it forms a conjugate base and a conjugate acid, right? And acid lose the hydrogen and base gains the hydrogen. Yeah. And what else is on your guys' study guide?
I want to go over the diagram if someone confused with me too about the BKA1, BKA2. There is a question on a study guide. Let me just pull.
What study guide's that?
For second study guide for the BKA base acid study guide.
Is it 1.2?
No, it show us the diagram and then it tell us like what is going on in BKA1, BKA2, BKA3. Have someone remember it? It's something like this. Something like this diagram.
Oh,
I had it, but I don't know where.
and like where you find like that isoelectric point and stuff like that.
There is a question on study guide, yes, for base acid questions. I didn't know how to answer it. Just give us diagram, and then I'm pretty sure he will include this in the exam because he said he will include a diagram, like a curve diagram, and will ask us what is going on in BKA1 and BKA2.
And he'll give you the amino acid, right?
I think so, yes, he will give us the amino acid.
Is that?
Oh,
Wait, let me
study guide 2, where it says draw the titration curve for the amino acid aspartate. Clearly indicate where the 3 pKa points and the TI
Yes.
on the curve.
Yes,
Yeah, I don't know
exactly.
how to study that, actually.
I didn't know how to answer it though. I kind of go over the study guides.
For that kind of problem, I would say look at this answer key. This one. See at the first point A, let's just say, it loses a hydrogen from the carboxyl group.
Mm-hmm.
And then at B, it loses the hydrogen from right here.
Why those two exactly? I mean,
Because this is the, when the reaction starts, it's acidic, right? It's gonna attack the acidic group, the carboxyl. And in the intermediate steps, it's gonna attack these 3 ones. It's KB, it's like basic.
okay. And K3, I mean part C.
Part C is K constant. It's deprotonating the carboxyl group again. It says right here, Ka, that means it's highly acidic. Ka means acid.
Why haven't my guards caught these intruders yet?
Mr. Olberg, do you still clam chowder?
And it loses the hydrogen from the carboxyl group. And then it lost, see how you put this right here? You're losing a hydrogen from these 3.
And me on a 1,500 calorie a day.
From each group 1 hydrogen, like basically I'm losing 3 hydrogens. Or just one of those things will lose 1 hydrogen.
I would say, I want to say all happens at once.
And the rest 2 will keep their protons with them?
Yeah, because like at point B, the amount of reactant and amount of product is equal. So whatever you take off from the one side, it'll be given to the other. So if you take all 3, don't forget that you want to draw all 3 for the products too. And then at case C, that's when the final step happens. K constant. Does that answer your question?
Yes. I'll go over it again. I'm just feeling confused about the diagram itself. So I'm going to go over it again and see if we can
Okay, they just want to know what happens like when it's highly acidic. Right now there's a pH of 2, right?
Yes,
What group is it going to attack? Oh, attack the
the
carboxyl group.
acidic.
And then at B, it'll attack this. And then at C, it most likely to going to attack the amino group.
What about if you give us like a different amino acid?
If you think about it, they all have 3 chains: acidic, basic, and R group, right?
Yes.
So the first one, if it's a very low pH, then it
So,
will attack the carboxyl.
so the OH here is the R group, right? And B, point B.
Yeah, this is right here. This is a carboxyl group.
And point B, it's the R group. Okay, cool. Thank you.
You're welcome.
Does it always start attacking the, what is it, the amino group?
Start with it or end with it?
Either or. What would it attack first?
It'll go with the carboxyl group.
Okay, first carboxyl. Okay.
Yeah, because if you look at this equilibrium equation at the top,
Oh, okay.
it depronates the carboxyl group.
Okay.
Yeah. And I'm not sure how he's going to test you guys on the protein structures. So, any questions about that part?
Have you taken this class before with them?
I took 155A with him.
Oh,
Yeah. It's pretty much similar, but I think there's a little bit more stuff that you guys covered than us towards the end. Yeah, you guys go in more depth.
not for us. There is something I highlighted. It's oligomer. When it's two on the subunit protein chain, when I said heteroterms, 2 beta and then 2 helix. Do someone do this too? Or just me?
I don't know which one you're talking about.
It's on my. Oh, okay. Never. Sorry, never mind. I'm looking to the wrong one. I'm looking to the 4th structure. It's not included in our exam.
But the quaternary structure is not included?
I don't think so. No.
Okay. And do you guys feel confident about the PI? Isoelectric point?
Formula for it, pKa plus pKa over 2.
Yes.
But what are the 2 pKa's? That, like, is it on the curve?
The pK values, the way you want to pick, if it's a neutral atom, then you do the 2 pK values are very close to each other. If it's an acid, like an acidic group like aspartate acid or glutamic acid, then you do a pK value of the R group and a pK value of the acid group.
Okay.
If it's basic, then you do a pK value of the R group and a pK value of the basic group divided by 2. Every time it's divided by 2.
Is there like an example that we can do?
Yeah. So what would be the PI for lysine?
How do we know if it's neutral, acidic, or basic?
You're gonna have to memorize though if it's polar, non-polar, if it has a charge, if it doesn't have a charge.
Oh, memorize? Okay.
Memorize those, yeah. And pKa 1 for lysine is 2.18.
Mhm.
That's
No.
and the other one is 8.95. And the third one is 10.53. So our group, this is your amino group. Right here's your carboxyl. So what would be the PI? And how would you do it?
Since lysine is acid, it's base actually, sorry. And then I'm just gonna take the base values. 2 of the base values divided by 2.
So what would be the answer?
You said 10.5, 8.5, 8.95 plus 10.5 divided by 2.
Yep. And what would you get for an answer?
Actually, I don't have my calculator. Hold on. Well, let me calculate it.
Did you say 8.95 plus 10.53?
Yes.
Yes. So the answer is 14.1.
You forgot to divide by 2.
I did actually, but I think, yes, I did. I got 14.1. Is this
Yeah.
logic?
The answer should be 9.74.
974. Hold on, it's 8.95 plus 10.53 divided by 2.
Yeah, 974.
I don't know. I think I have something wrong with my calculator then.
8.95. Yep, it's 9.74.
Is there like a list that says saying which ones are acidic and which ones are basic? Like a chart?
No, you.
But you can find images online.
All right, with this, because he said this is going to be given on the test.
I think the only thing he'll give you, it's a chart just with pKa values and the amino acid name. He won't give you the structure.
I thought he said that he would give us like exactly this.
But that would be like, wait, can I see it? I mean, he's changing it then now. Yeah, then that's what he'll give you.
So we can determine with this if it's basic or acidic.
From their pKa, you will know if it's basic or acidic. Because if you know the pKa, you will know the charge. If you know the charge, if it's positive, then it's base. If it's negative, then it's acidic. Isn't it like that?
I just remember the chart.
Can someone send me the charge, please?
Okay,
Because this is a chart that I normally use whenever I want to study.
Oh, okay. Wait, let me take a picture of that. Okay, got it.
Because the plus charge ones are basic and the negative charge ones are acidic.
Mm-hmm. And then for the nonpolar and polar, would we have to get the PI for those?
Let's see. So these are the ones that have on art chain or the art group. There are only 5.
Oh, okay. So we just have to know those.
Yeah. You just have to know those.
Okay, got it.
The other ones are just PKA1 plus PKA2. You guys can either take a picture of that or write it down. That's fine. If you look at it, these 2 are acidic. These 2.
Mm-hmm.
And these are basic.
And
Any
if
other?
they're acidic, you add the pKa2 with pKa3, right?
For acidic, you add pKa1
Oh, okay.
with pKa3. Because pKa1 is carboxyl group,
Mm-hmm.
pKa2 is amino, and pKa3 is the side chain.
Okay. And then the basic ones are 2 and 3.
The basics ones are right here. Glycine, arginine, and histidine.
Yeah, but pKa2 and 3 is what you add.
Yep.
Okay, got it. Okay.
Any other questions that you guys want to go over? Do you guys have to memorize the 3-letter words for the amino acid? The 3-letter alphabet? No?
No, we don't.
Okay. Any other questions for me?
Can you repeat what did you say, how we add BKA1 to BKA3?
Yes.
Thank you.
No problem. So if it's a neutral atom, you do the pKa1 plus pKa2 divided by 2. If it's acidic, then you do pK of the carboxyl group with the pK of our group divided by 2. If it's basic, then you do the amino group and then the R group. And there are only 5 that either requires acidic or basic. 3 for basic, 2 for acidic. Out of 20 amino acids, there are only 5 amino acids. And this,
I got
this
it.
would
Thanks.
this would be amino and carboxyl.
And then the last thing, the basic, is just the pKa of amino, and then pKa of R. Is this R?
Yes, that's R.
Okay, cool. Thank you. Got
R
it.
group.
Can you go over question 4? I got it wrong the first time.
On the quiz,
Yes, on the quiz, please.
so the question is, you make a buffer composed of 1 liter, 0.1 molarity of sodium acetate and 0.2 molar of acetic acid.
Mm-hmm.
pKa value 4.76. You then add 0.01 mole of NaOH. What's the pH? What do you guys think you're gonna do?
That's the one where you take the pKa and then add the what is it, the base over the acid, right?
That's a Henderson-Hasselbalch equation. Yes, we're gonna use that.
Mm-hmm.
But is that the first thing we're gonna do?
I'm not sure I got it wrong. So
So when you're adding something, that means you're changing the volume, right? That means you're gonna have to do an ice table. Do you guys remember doing that part? Yeah, no?
Yes, kind of. I remember. Oh, stable.
So you have
The equilibrium table.
1 liter of 0.1 mole. I'm sorry? What did you say?
I said, is it equilibrium table?
You can say that, yes. Because in this one, we're adding something, right? We know our pK is 4.76. And our base is 0.1 moles. And our acid is 0.12 moles. If you plug it in like this, you'll get a wrong answer. Because the problem says that we're adding 0.01 moles of NaOH.
okay.
So we know that we're reacting NaOH with acetic acid to form sodium acetate. And do you guys know how I got that equation?
I don't.
So they're telling us that in a buffer solution we have an acetic acid and sodium acetate, right? And we're adding NaOH. When we're adding NaOH, are we making more base or acid when you add NaOH?
More base?
You're making more base. So we're reacting NaOH with acetic acid to make more base, which is sodium acetate. And they tell us that there's 0.01 moles of NaOH. And acetic acid is 0.12 moles. And sodium acetate is 0.1 moles. What do you think is the change? What do you think the change is?
We will add 0.01 moles to the base moles, like 0.1 plus 0.01, and then we will subtract the same amount from the 0.12.
Perfect.
Okay.
And what do you get as the answer?
I don't have my calculator. Someone do it.
Okay, for acetic acid, you get 0.11. And for sodium acetate, you also get 0.11, right? And then we take these numbers and plug it into the Henderson-Hasselbalch equation. So the new equation would be
4.76.
this would be 0.11, 0.11. And when you take the log of this, what do you get as an answer?
0.
Yep, so it'll be the log of 1, which is 0. So 4.76 plus 0 is 4.76. So just remember, when you're adding something, you want to do the ice table, unless he tells you that there's no effect of the solvent added.
Wait, what's the ice table? This is the one you showed us?
Yes,
Okay, that's what it's called.
this is initial change.
Okay.
I go with equilibrium, but some people go as final.
Okay.
That's it for today. Do you guys feel more confident for the exam now? A little bit
I
more
do.
confident? Okay.
Thank you so much.
Thank you.
You're welcome. Good luck on the exam.
Thanks.
Bye.
Bye.
Huh? Yes. Thank you.